whole story about personal computers, usually called PCs, started with the IBM's decision to use Intel processors in computer design. The family of x86 processors, as we call them now, began with the Intel 8086 microprocessor introduced in 1978. It is worth noting that the first IBM machines, the IBM PC and IBM PC XT, used the cheaper 8088 processor. It was software compatible with the 8086, but because it used an 8-bit external data bus, it reduced overall computer cost. Later, IBM used the 8086 processors in personal computers named PS/2. The successor of 8086, numbered 80-286, was used in the IBM AT personal computers, the extended version of the XT, and in the IBM PS2-286 machine, which became the standard architecture for a variety of personal computers designed by many vendors. This started the history of personal computers based on the x86 family of processors. In this video, we'll briefly describe the most important features and differences between models of x86 processors family. The 8086 is a 16-bit processor, which means it uses a 16-bit registers and a data bus. With the use of the segmentation operating in so-called real addressing mode and the 20-bit address bus, it can access up to 1 MB of memory. The base clocking frequency of this model is around 5 to 10 MHz. It implements a 3-stage instruction pipeline, which allows the execution of up to 3 instructions at the same time. Together with the processor, Intel designed a set of supporting integrated circuits intended to build the whole computer. One of these chips is 8087, a math coprocessor, currently known as the floating point unit. 8186 model is considered the faster version of the 8086, and it class some additional hardware units and is designed to reduce the number of integrated circuits required to build the computer. Its clock generator operates between 6 and 20 MHz. 80-286 has an extended 24-bit address bus, so theoretically it can access 16 MB of memory. In this model, Intel tried to introduce protected memory management, but due to the problems with compatibility and efficiency, extended features were used by niche operating systems only. The most recognized one was IBM OS 2. The 8386 made a significant step forward in the x86 family of processors. It is the first 32-bit processor designed by Intel for personal computers. This time, protected and virtual memory management works okay, and it was successfully used in operating systems, certainly including Microsoft Windows. All architectural elements of the processor, like registers, buses, arithmetic units, are extended to 32 bits. 32 bits allow addressing up to 4 GB of memory. The 8386 extends the instruction pipeline with 3 stages, allowing for the execution of up to 6 instructions simultaneously, and the clock speed could reach 40 MHz. Another important functional unit in this is the cache. Although no internal cache was implemented, this chip enables connecting external cache memory. With the 8386, Intel started the IA32 architecture and instruction set. The original 8386 name was later replaced with i386. The i486 is an improved version of the i386. Intel combined in one chip the main CPU and the FPU, except for ASIC versions, and memory controller, including 8 or 16 KB of cache. The cache is 4-way, associative, common for instructions and data. The processor implements a 5-stage instruction pipeline, with every stage operates in 1 clock cycle, and the clock frequency can reach up to 100 MHz. The successor of the i486 processor is the Pentium. The first Pentium is still a 32-bit processor, but implements a dual integer pipeline, which makes it the first superscalar processor in the x86 family. It can operate with a clock frequency up to 200 MHz. An improved microarchitecture includes a branch prediction unit, which helps to reduce the influence of pipeline invalidation possible for conditional jump instructions. The cache memory separate for instruction and data is 8 KB each, both free-weight associative. As you may note, the name Pentium is still used by Intel for selection of modern 64-bit processors. The first processor which implements the single instruction multiple data instructions is Pentium MMX. This version uses physical registers of the floating point units for 64-bit MMX vector operations. The clock speed is up to 233 MHz. Intel also decided to improve the cache memory as compared to the Pentium. Both instruction and data caches are twice as big, having 16 KB, and they are 4 ways associative. The Pentium Pro implements a new architecture named P6, with many innovative units, which enhance the overall performance. The instruction execution is organized into a 14-stage pipeline. The advanced instruction decoder generates microoperations which can be recognized as RISC-like translation of the x86 instructions. It can produce up to 2 microoperations representing simple instructions and up to 6 microoperations from the microcode sequencer, which stores microcodes for complex instructions. Microoperations are stored in the buffer, called the reorder buffer or instruction pool, and by the reservation station are dynamically assigned to a chosen execution unit. In Pentium Pro, there are 6 execution units. An important feature of P6 architecture is that instructions can be executed in an out-of-order manner with the flexibility of the physical register use known as register renaming. Also, these techniques allow for executing more than one instruction per clock cycle. Additionally, Pentium Pro implements a new extended paging unit, which allows addressing of 64 GB of memory. The instruction and data L1 cache have 8 KB in size each. The physical chip also includes the L2 cache of up to 1 MB in size. Level 2 cache is assembled as a separate silicon die. This made the processor very expensive, so it wasn't targeted for the consumer market, but mainly implemented in servers and supercomputers. Pentium 2 is the processor based on experience gathered by Intel in the development of the previous processors, Pentium Pro and Pentium MMX. Pentium 2 combines P6 architecture with SIMD instructions. This processor operates at a maximum frequency of 450 MHz. The level 1 cache size is increased to 32 KB, split to 16 KB for data, plus the same size for instructions. Intel decided to include the level 2 cache from the processor's enclosure and assemble it as a separate chip on a single PCB board. Thus, Pentium 2 doesn't have the form of a chip, but rather a PCB module. This approach has caused slightly worse performance, but it made Pentium 3 much cheaper than Pentium Pro. Besides, the implementation of multimedia instructions made it more attractive for the consumer computer market. So it became very popular among private consumers. Pentium 3 is very similar to Pentium 2. The main enhancement is the addition of the streaming SIMD extension, SSE. Introduction set accelerating SIMD calculations and floating point numbers. Due to the enhancement of the production process, Intel was able to increase the clocking frequency to the range of 400 MHz up to even 1.4 GHz. Pentium 4 is the last 32-bit processor by Intel. Selected late models also implemented 64-bit enhancement. What is important is it is based on net burst architecture, which was developed as a possible improvement of the P6 architecture. The significant modification in shifting the instruction cache from the input to the output of the instruction decoder. As a result, the cache called the trace cache stores microoperations rather than instructions. To increase the market impact, Intel decided to enlarge the number of pipeline stages using the term hyperpipelining to describe the strategy of creating a very deep pipeline. A deeper pipeline enabled higher clock speeds up to 3.8 GHz. Intel used this feature to build the marketing strategy. The Pentium 4's pipeline in the initial model is significantly deeper than of the preceders, having 20 stages. The Pentium 4 Prescott processors has an extremely deep pipeline of 31 stages. Intel also implemented the hyperthreading technology in the Pentium 4 HT version to enable 2 virtual cores in one physical processor. These logical processors share the workload when possible. Because the technology of producing chips also evolved, the Pentium 4 Intel required the single chip package for both the processor core and the level 2 cache. Pentium 4 extend the instruction set with SSE2 instructions and Pentium 4 Prescott with SSE3. Net burst architecture suffered from high heat emission, causing serious problems with heat dissipation and cooling. Of course, Intel wasn't the only one developing processors. Until the Pentium, there were competitors including AMD, Cyrix, Texas Instruments, and NextGen. After the launch of the P6 architecture, AMD was the only company that could compete with Intel. Intel embarked on the ambitious projects of developing a new 64-bit architecture and began work on the Itanium processor. The architecture name was IA64. AMD, on the other hand, decided to extend the 32-bit architecture with 64-bit in the same way the first 32-bit processor was designed, by expanding the number of bits in registers and internal circuits, leaving the processor fully compatible with the x86 family. This led to the creation of the Opteron, the first 64-bit processor, launching a line of processors first called at the beginning AMD 64 or x86 64, and then simply x64. Versions of Opteron include the initial one-core and later multi-core processors. AMD Opteron processors implement x86, MMX, SSE and SSE2 instruction known from Intel processors, and also AMD multimedia extension known as 3D-Now. Until now, AMD has been a very strong competitor for Intel, with many interesting versions of processors, including the popular Ryzen family. After facing problem with heat dissipation in the processors based on the netburst architecture, Intel designed the Core microarchitecture, derived from P6. One of the first implementations is Pentium dual-core. After some time, Intel changed the name of this processor line back to Pentium to avoid confusion with Core and Core 2 processors. There's a vast range of core processor models with different sizes of caches, number of cores, offering lower or higher performance. Currently, Intel produces core processors, high-performance Core Ultra, and Xeon for servers and high-performance computing machines. Fortunately, all modern 64 processors differ between Intel and AMD, and between models, they share a similar instruction set. And for this course, we can assume they are compatible.